All right, part two of lesson one. We're going to finish up here with the combinations. Again, combinations, order doesn't matter. Cards in your hand, the order in which you got those 5 cards doesn't matter because it's the exact same hand and the exact same 5 cards that you get to use to play whatever that round of poker or euchre is. So when your order doesn't matter, you're dividing by more since there are duplicates, right? So we have to divide out the duplicates. We usually have n factorial divided by n minus r factorial for the permutation, but the combination adds another r factorial because there are less possibilities because you're dividing all of the duplicates out. You're getting rid of them. So one of the things that students might struggle with is deciding, is this a permutation or a combination when they're reading through scenarios? So exercise 7 is just to help you decide if this is a permutation or a combination. So I'm only going to show you 7a. We'll do that together, and then you should pause and try B, C, D, and E on your own. So 7a, so it just says here, this is like what you're going to see on the quiz or test as well. I want you to see this direction. It says, decide if each scenario involves a permutation or a combination, then find the number of possibilities, leaving answers in factorial, NPR, or NCR form. So here we're leaving it in factorial form like this, or we're just leaving it in NPR form. Either of those are fine. We're not asking you to calculate, because on a non-calculator section, we don't want you to have to do all those calculations, so you can leave them in these forms instead. Okay, 7a says, Cash and Walker are planning trips to 3 countries this year. There are 7 countries they would like to visit. One trip will be 1 week long, another 2 days long, and the other 2 weeks long. So why are we saying this is a permutation where the order matters and not a combination? Well, it's because of the length of time that they're spending in the countries. If you spend 1 week in a country versus 2 days, we are saying your experience would be different. If you get 2 weeks in a country versus 2 days, that experience in that particular country is going to be different because you have more time or because you have less time. So this is 7 different countries you have that you can choose from. The order matters, so it's a permutation. You're going to 3 countries because you have one for 1 week, one for 2 days, and one for 2 weeks because those are different. The order matters, so it's 7P3. So why don't you try the other ones now, pause, and see how you do. Okay, if you didn't pause and you just looked at the next one, here's 7B. It says a group of 25 people are going to run a race. The top 8 finishers advance to the finals. Well, it doesn't matter who came in first, who came in second, who came in third. All of the top 8 finishers get to move on to the finals. So you have 25 people that ran. All 8 of them, the top 8, get to go. So the order in which those top 8 came across the finish line doesn't matter. So it's a combination. There's 25 runners, and we're choosing 8 of them, and the order doesn't matter, so it's 25, choose 8. For C, you have 17 softball players, 3 are filling the water cooler. It doesn't matter which 3 we choose or in what order we choose them. So it's 17C3. For D, the student body of 10 students. Now, because we are giving someone the title of president, secretary, and treasurer, the order matters. If I'm president versus my friend Sally being secretary, and we switch and she's president and I'm secretary, well, that's a totally different role for both of us. So that order matters. So that's 10 people to choose from. Order matters, so it's a P, and then 3 positions that we're filling. So 10P3. And letter E, there's 15 applicants for 4 jobs. Because those jobs have different titles, you are doing different things, then the order matters. So there are 15 people to choose from. The order matters, so it's a P, and there's 4 positions. Okay, question 8, going back to our cards. So we have 52 cards in a deck. There are 13 cards in each suit. There are 4 suits, clubs, spades, hearts, and diamonds. You have 4 of a kind, so 4 aces, 4 twos, 4 threes, etc. You have 12 face cards because there are jacks, queens, and kings. So this is everything you need to know about this 52 cards in a deck. So how many different 5-card hands are possible? Well, there's 52 cards. The order in which we get them in our hand doesn't matter, so it's 52, choose 5. The left-hand subscript is the amount of cards we have to choose from. The right-hand subscript is what we want to end up with in the end. So it's 52, choose 5. Part B says, how many of these hands will have, okay, part 1, all diamonds. Well, there's only 13 diamonds in a deck of cards. So we have 13 diamonds we're choosing from. The order in which we select them or get them in our hand doesn't matter, so it's 13C5. We have 4 black cards and 1 red card. We have 26 black cards in the deck. There are clubs and spades, so 26 cards to choose from. We want 4 black cards. But remember, the word and means multiplication. So we have 4 black cards, 26, choose 4. And multiplication, 1 red card. Where those 26 red cards, the order in which we receive that red card does not matter, so it's 26, choose 1. My 2 right-hand subscripts total the amount of cards in my hand, which are 5. My left-hand subscripts total the amount altogether, which is 52 cards in the deck. Okay, part 3, I'm going to cover up the solution and have you just read it, or I can read it. So how many of these hands will have 3 kings and 2 queens? Well, how many kings do you have to choose from? You have 4. So you have 4 kings, you're choosing 3. Does the order in which you get those kings matter? No, so it's a combination. The word and means multiplication. You have 4 queens, you're choosing 2. So what does that look like? Now, what is the difference between part 3 and part 4? So here it's 4, choose 3, 4, choose 2. We have 5 cards we're choosing all together. If this says 3 kings and it doesn't specify the other 2 cards, well, this word, it wouldn't be exactly 3 kings, might be a little bit better, but we have 4 kings to choose from. We want 3 of them, and we can have 2 of any other card. We don't care what they are. Well, you remove all of the kings because you only want to have 3 of them left. Or you only want to take 3 of them. You can't add that 4th one into here, so you only have 48 cards to choose from, right? Because you don't want a 4th king, you only want 3 kings. So there's only 48 cards left because 52 minus the 4 kings is 48. And we're choosing 2 from the remaining 48 cards. My right-hand subscript is 5. This left-hand subscript is 52. There's 52 cards in the deck. So maybe try 5 and 6 here on your own. What would that look like if you had 4 tens? What would that look like if you had 5 cards of the same suit? So pause and try it on your own. Okay, is this what you got? 4 tens. That means you have 4 tens. You're choosing all 4 of them. But you have 1 more card you need to select. So, and you need 1 more card. Well, the 4 tens are gone. We don't need any more tens, or we don't have any more tens to choose from. We have 48 cards left. It could be any one of those 48. So it's 48, choose 1, times 4, choose 4. 5 cards of the same suit. Well, that would be 13 cards you're choosing from. You want all 5 of them to be from the same suit. But you don't just have diamonds. You have diamonds, hearts, clubs, and spades. So we have 4 different suits, and this is how you would get all 5. Remember up here from the diamonds, how you'd get all 5 to be the same suit. Because there are 4 suits, clubs, spades, hearts, diamonds, times 13, choose 5. And that's it. So hopefully you understood. Try the homework, see how it goes, check your answers, and then of course, since you weren't in class today, you might need to follow up with your teacher should you have any questions, or come see any of us pre-calc teachers and we'd be happy to help you. Enjoy your evening. Bye.